Welcome to the Techne Automotive podcast, aimed at inspiring the next generation of EE-related talent to choose a career within our space, whilst also supporting the current EE talent pool in making key career decisions. In each episode, we interview industry leaders to discuss their unique career paths, advice for those starting out in the automotive industry, as well as important issues currently impacting the sector. My name is Ferris, and I'm responsible for connecting automotive businesses to the best EE-related talent. Today, we are joined by Grant Smith, who's the Chief Engineer for EE Architecture and Software at Volta Trucks. Grant originally became interested in automotive after completing the Formula Student project in his final year at university, so I'm looking forward to receiving his views on this. He has since achieved an impressive CV, including roles at McLaren Automotive, Gordon Murray Design, and most recently Volta Trucks, where he's been with the company since it was a startup and has been a key player in its rapid growth. In this episode, we'll explore his outstanding achievements to date, his advice for starting out in their career, as well as his insights into the future of the industry. Morning, Grant. First of all, welcome to the podcast.
Morning, thank you.
How are you?
I'm good, thank you. You're really good.
Good stuff. So just can you start with some introductions, if that's okay?
Yeah, so Grant Smith, so I'm Chief Engineer for EE Architecture and Software at Volta Trucks. I've been with the company pretty much since it started its journey as a startup. Just over 2 years ago, I started with them now. In a rapid growth area of the industry.
Absolutely. And we're obviously going to go through your career shortly. You've had some interesting projects, to say the least. But before we go into your career, who's Grant outside of work?
Yeah, so now my outside of work life is predominantly with my kids. So I've got 3 kids under 5. Which keep us very occupied. It was my daughter's first birthday this weekend, so yeah, it was. It's always every evening, every morning, every night. They're always keeping us occupied with doing stuff. So, but we enjoy that. That's what we like doing. And my wife and I are both very outdoorsy. We've always travelled and done lots of sports, and it's part of what we are with the kids. We're always going out every day doing stuff, whatever it might be. My background's mainly in cycling, and my wife's is in running. So that's what we've done outside of our careers.
Brilliant. We'll jump into your career. Do you want to start with where you studied?
Yeah, so I studied at Warwick University. There I studied electronics and communication engineering. Great foundation course into the core technology of that area of the business. Wasn't targeted specifically at automotive in any way. It was the fundamentals of electronics and electrical engineering. And where I then moved towards an automotive sort of speciality was during my final year and getting involved in Formula Student. So I was part of the Warwick Formula Student team, where there was a few of us started working on the electronic aspects of the vehicle and building a basic architecture, some electronic displays, communication, integration of the engine control module. And that was a real sort of kickstart into both the technical and the non-technical aspects of sort of a real time deliverable basis project. And that's where my tutor for that project also had his own small company on the business park. And at the end of my degree, he offered me a grad placement working for them. I went and worked with them for 6 months initially just on a grad placement, and then they offered me a full-time grad position working with them. I stayed with them for a while before then moving on to Vistion, based over in Essex. Working on diesel combustion engine controllers, but on the CAN communication stacks and the communication protocols for them integrating onto the vehicles. And that was a good exposure then moving from the small business to a larger business and a real global business environment. And then after that, I then was lucky enough to get a position at McLaren Automotive, where
Fantastic.
They were just finishing the end of the SLR program. So I sort of spent my first sort of 6 months a year working on finishing up the McLaren Mercedes SLR projects. So the 722, the Spider, and the Sterling Moss edition. So finishing up on the Sterling Moss edition vehicle. So that was a great start, and moved on then to the MP412C, working on some critical components there. Joining the program a little bit late, having finished up on the McLaren Mercedes projects, but then overseeing and being the owner of a number of electronic components on the vehicle. So things like the instrument cluster, door modules, more body systems, but the ones that hadn't quite progressed as quickly as the core powertrain and chassis systems. And there I owned components through the full life cycle, going to drive events, getting exposure to the complete business, and working on that. And then moved through to the end of that program, and then moving on to some of the Spider products. And I left then McLaren after about 5 and a bit years, just as we were sort of starting into the P1 program. And I went and joined Gordon Murray. And that's where I then spent sort of 18 months with him working on, and I was responsible for all the electronic architecture, including the e-powertrain on some prototype vehicles with him, and leading sort of more of a wider breadth of exposure for me. So it gave me a good opportunity to work on battery systems, inverter electronics, and working with external partners to really learn from the ground up, because that hadn't been my core area of expertise previously. That was starting to come to an end, and at that point there was always a request or interest for me to go back and help out with some critical topics at McLaren. So I ended up going back to McLaren, which wasn't my intention when I left the first time, but it was still the right decision. And I went back as principal engineer for body ECUs for a bit, to help out with some critical aspects there. But moving with the ambition of moving full time into the E architecture domain. So there was a roadmap towards the new E architecture, which you now see in the Artura. And so that was where I started leading more of the E architecture responsibilities there, which was the culmination of the McLaren Automotive project, basically. Near the end of that is when then I left and joined Volta Trucks initially as E architecture and software manager. I'm now chief engineer, and my responsibilities now, I've got 5 main areas. So I own the control system engineering team, who write the requirements for how the functionality of the vehicle works, all the network design and the architecture concepts of how we integrate everything onto the networks, the embedded software on the vehicle, and the delivery of that, whether it's off the shelf, slightly modified, or completely bespoke to our requirements. All the diagnostics solutions, both on the vehicle and integrated with the off-vehicle diagnostic tools, and then a DevOps team as well for integrating all our tools and processes together.
Fantastic. I think if you could go back and sketch out your career, I think you've done very, very well so far in regards to what you've worked on. Obviously, what you're doing now is it's a testament to yourself. I just wanted to pick up a point about forming the student. Obviously, it's a big discussion point, and we'll talk about that a little bit more in detail through the podcast. But that was one of the key influences, wasn't it? Really, to steer you into maybe looking at the automotive and motorsport industry in general.
Yeah, definitely. It was the first conversion from everything being theoretical in university, so theoretical projects where you still had timing and you still had an objective to meet, but it wasn't a perceivable outcome as such. You delivered a thesis or a document and you got a score at a point. But working on the Formula Student was a real eye-opener to sort of race day mentality. There is no moving the deadline. If you turn up with a car that doesn't work, you turn up with a car that doesn't work, and that's what you stand in front of, and that's your responsibility. So moving into that environment and seeing that was really sort of my sort of introduction to what I found to be the exciting part of converting from just doing theoretical engineering to real engineering on a product.
Yeah, no, absolutely. And going through your career, you've worked on some interesting things, but what's been your flagship moments, ultimately what you're most proud of so far?
Yeah, so on top of the Formula Student thing, which we just talked about, the MP412C, because that was then moving from to a true business mentality of there was a company, there was a financial responsibility to meet, there was a timing to meet, and the company was growing massively. We were expanding and leaving the Mercedes umbrella and moving towards our own brand, and taking that challenge on was a big thing. And then also taking the risk and expanding my technical horizons, moving with Gordon Murray and getting involved in the e-powertrain concept and the deliverables of those. McLaren Automotive as well, sort of having the basis of the idea behind all the architecture concept, changing the tools, the processes, the product itself, and moving that towards what it is now. And then using that again as the basis for my experience to start Volta from scratch. So Volta is entirely from scratch my responsibility, whereas everything prior to that was either derived or I was a fast follower or involved in the early concept, but not my entire idea.
Exactly. For people who don't know, obviously, you'll read the magazines and you might see the McLaren Artura and go, oh, another McLaren. But actually, behind the scenes, from an EE perspective, that was huge, wasn't it?
Yeah. So it's well over 90% completely new EE architecture from the ground up. So yeah, a completely new tools, processes, product, everything involved in it, basically. Completely designed from the ground up.
Absolutely. And obviously, Volta Trucks, as a business, you built that from the ground up, ultimately from an EE perspective, haven't you? One of the first to go in there.
Yeah, we have no parent company, so we have no access to any off-the-shelf components from a lead OEM. We are our own company. We can obviously source components that are available in the market that have been developed for other OEMs, but they are not under our design control necessarily. We are just going to the market and finding those parts, and we have to fill the gaps where we can't find what we need. So developing some parts of the architecture ourselves, but recognizing our core aspiration is to get to market quickly. We cannot go and design everything from scratch like a normal OEM would, and sort of expect to spend 8 years developing that from scratch. We've got a 2-year plus time to market that we really had to meet for a number of reasons, and so that has a massive influence on the way you approach the design and what you choose to design and where your risk level is. It's very different.
Brilliant, great insight. So you look through your career now. If you could now go back to Grant at 16 years old, based on everything that you've learned, what would you tell yourself?
So I think I had a close call when I nearly completely screwed up my A level. Took a little bit too much time to enjoy life, the opportunity to start enjoying life, and I managed to scrape through into university. But that gave me a real reality check to try and start realizing that I wanted to do this, and it was really enjoyable. And so I started to knuckle down and get really involved in trying to catch back and get on top of a number of the topics. I failed at a couple of topics in university spectacularly, but they gave me a massive learning opportunity to realize what went wrong and how to change that. So the failures aren't necessarily bad things if you react to them correctly. They can really turn things around. And I can call out some very specific projects I worked on. And I just look back and go, how did I get it so wrong? But actually, getting it completely wrong changed my mental approach to solving it and doing it in the future. And it's something I do day to day now completely differently. So there's that. I'd say realizing that the mentality. So realizing how you can apply a can-do mentality to anything, you just keep going. There's no reason to stop other than you give up. So if you just keep going and you have that can-do mentality, whether it's what you learn in university or you start out with or you adapt to doing, you'll find it valuable in any business. Any business will like people and value people who just have that mentality to do the can-do thing and keep going and keep involved. And then I'd say jumping through obviously all of my career points, that they are all based off one fundamental, which is the learning from university. So that core learning and the where you start from and the fundamentals that you learn, if you really get that right, expanding from there with can-do mentality, you'll find yourself in a position of strong capability and leadership potentially. And they just enable you to then expand further in future. So the core engineering fundamentals is something I'd call out as being a real key point.
Yeah, and it's that blend, isn't it? When we discussed behind the scenes, it's a blend of engineering fundamentals and getting that right, and then obviously right mentality, which is personal, and then also trying to blend it with commercial acumen. So sometimes what you can do, you get deep into engineering and you can completely forget that it needs to be commercially viable on all accounts for the business to run. And I think what you've done really well is you've adapted your mind early, hence why you probably progressed so quickly.
Yeah, if you use the technical fundamentals to then assess and learn and grow into business acumen, you'll find that you present good, justified options at the start of being involved in business decisions, and then you'll realize later that you can actually recommend what the business should do because you can interpret what your technical decisions are having as an impact on a business, and then you'll then progress towards the point where you actually can be trusted to be the leader and don't need to seek approval. You're given the free rein of saying, I trust that you're going to make the right business decision. You don't need to justify it to some degree. And as you build yourself up to the point where you're then effectively the leader because you're both making the right technical decision and the right business acumen decision for the company you work for.
So if you take your fast cycling career and then you brought it into the world of an automotive career, I think what you've done, and you've done incredibly well at McLaren Automotive. You worked on some really fast-paced, demanding projects. Obviously, McLaren or any type of motorsport environment is demanding. You then turn your hand to Gordon Murray, which is probably a similar environment. You've then gone over to a brand new startup, trying to do things in very, very quick time, and it's high pressure, but it's a challenge that obviously is a key motivation. But stripping all that back, what's been the key ingredients for Grant to actually execute these challenges?
Yeah, so I definitely refer back to the core engineering technical principles. Don't necessarily, you've got to find yourself in a balance where you can make risk-based decisions. So everything that you do, whether you're writing a piece of code and you've got a deadline to do it today or within a week, you'll make a risk-based decision on how complex or how complete or how much risk you're willing to take of providing an uncommented piece of code or whatever it might be. These are all the risk-based decisions you should think about consciously. Am I making the right decision? And start thinking about how you're making the decision more than just the decision and the outcome. And as you evolve into those assessments, as you're doing it and realizing you're making those assessments, you'll start realizing what you're doing subconsciously sometimes. And so a lot of the decisions, I mean, I'm still involved in meetings daily on sprinting in code development and making a decision on what to prioritize or not, because there isn't enough time, there isn't enough money, there never is. There is no world that we work in where there is enough time or money to get everything done perfectly. So realizing that now means that you whatever you start on, whether it's a university project or a real world deliverable within the company, you if you start out realizing that there isn't enough time, there isn't enough money, and always start thinking about what's plan B if plan A doesn't work, you'll start getting the right approach to all the complex problem solving that you'll face.
Brilliant. And obviously now you're leading teams ultimately, and you're leading the full EE spectrum. How have you adapted that approach into leadership?
So yeah, a good question. So the biggest transition from being the technical expert is to then being the leader of a technical team. And there's a balance between knowing you could get involved in every topic, but actually then you'd never have a single hour of the day to do anything else. So you have to realize at some point you've got to start delegating. And to delegate, you've got to have a team that you implicitly trust. So the way I've tried to approach this mentally is I've always hired people who I trust to be technical experts or better technical experts a lot of time than I could be on a certain subject.
Yeah.
And what they want from me is the right leadership of what to choose and prioritize. So we're aligned very well on the technically what we should do, and they can give me good options and ideas of what they think is the right solution to a problem, or I can challenge them with some good ideas or options if I get a different requirement to achieve the end goal. But as a team, I empower them to make the decisions and work autonomously. I can't be the person standing there overseeing what they're doing every day, every minute of every hour. The team's nearly 30 people strong now. And so I lose touch with some of the people that I originally hired. I can't meet with them face to face as I used to do in the first instances and have meetings with them. But they all know that they can reach out to me if there's a problem. But they also know to normally just go through their line manager. But we all have a sort of a background understanding that anyone in the team can try and help out. Everyone is there to help out with each other. There's no silos. There's nothing like that in my team. And the core technical experts and the people are there to help everyone else out, basically.
That empowerment's absolutely key, isn't it? It's absolutely...
Yeah, definitely. Yeah, definitely. I think the other thing to call out probably is the different mentalities as well. So if you build a team of the same people, you'll find you'll get the same answer and no one will challenge each other. Having a discussion about a complex topic and seeing or hearing everyone just nodding and agreeing means either they're not listening or they're all agreeing and you've got the wrong team necessarily. Because if it's a challenging topic, you should find people who aren't in agreement or there is a problem to resolve. So having sort of a risk taker versus someone who's a finisher and a high quality output person, you put the two of them together, you'll get a good balance of a risky approach to a new problem that is finished correctly for the problem they're trying to solve. If you have lots of risk takers, you just get chaos. If you have lots of finishers, you get nothing done. So you've got to find some balance in the middle, basically.
Really interesting. So if we look at the EE automotive industry over the next 5-10 years, if people are going to choose to come into this space now, because it's fast evolving, it's still rapidly evolving at the moment. From your perspective, Grant, what do you think is coming up from a technical perspective?
Yeah, so outside of the architecture changes, we'll come on to in a second, that everything electronically is getting more complex. So each of the electronic products on the vehicle, an ECU, a sensor, and actuator, are inherently getting bigger and more complex. there are still small ECUs, small components, but there are the core where a lot of the engineering is going into is a highly complex ECU on an ever increasing complex ECU. So those are the fundamentals of the way that the E architecture is going, and they are enablers to then the change in the architecture concepts. So whether you go to something like a geographical domain controller, a zonal architecture, a central CPU, or a mix of these, they are all based off a number of core elements of your architecture becoming more complex than you previously would have had, where you had one ECU, one function, like a body controller, a HVAC controller, a lighting controller, or something like that. They are being amalgamated. You're merging domains sometimes, body, powertrain, chassis into one ECU, and having to overcome those issues. So they're the biggest challenges in the way that the industry is moving towards in terms of EE architectures, I'd say.
Yeah, no, absolutely. And just for listeners who might not understand what's happening within a vehicle itself, what's the reason why we're ultimately changing the architecture? Because we've obviously got ADAS that it's been talked about a lot, but a lot of people would say it's still not quite ready, but in the next 10 years it should be. But so what's coming up that's causing this change from your perspective?
Yeah, so the autonomy aspect is a big influencer. I think it's an initiator to the idea of a let's say a highly complex ECU, or like a hypervisor on an ECU running to amalgamate data. But beyond that, nearly all the OEMs are moving towards wanting to always cost and weight down. And a number of the architecture concepts like zonal or geographical or central CPU, they either as an enabler bring a lower cost, lower weight solution, but they potentially also bring some ability to support, or quite often do bring the ability to support things like software download, software reflash, or a new business model like selling software products after the vehicle is sold and providing an update pack. Sort of the concept of flashing a higher power engine ECU calibration to a vehicle that you've paid for a day whilst you're on a track day in a McLaren, that kind of thing that you can conceivably see people paying for, and you need an architecture that supports the concept of being able to do that, basically.
Yeah, no, absolutely. And if obviously from experience of hiring, obviously growing your department out now, everything that you saw at companies like McLaren and Gordon Murray, there's an argument to be had, isn't there? And there's no right or wrong in my opinion of, if you're coming into the sector, do you want to become and hang your hat on a specific technical specialism? Whether that's, I'm going to come in and be a cybersecurity expert, I'm going to come in and do functional safety, I'm going to come in and actually just become a complete base software whiz. Do you advise anybody to specialise in certain areas based on your experience?
There's no harm in doing it, but what I would say is that everything's based around the concept of software running inside an ECU. So whether you are the person writing the code, you're a functional safety manager assessing a safety goal and risks of code, and you're going through a fault tree analysis, and you're doing TARAs in the cybersecurity world now on the risks, and then how do you solve a risk identified from a TARA? You're implementing a solution. It's software based inherently. They always fall back on the people that have the core engineering expertise in that area. They're enablers to being either a specialist in one area or a wide ranging, like in my role. It's enablement of being, in that initial instance, a good understanding of your technical expertise, and then specialize further as you go along. So in my initial instance, I was a software engineer in that role. Then I moved into project engineering, so I got exposure to non-technical areas, and then I moved into other technical areas like doing e-powertrain, and then I moved back into more. I'm now moving back into more of a managerial role as a chief engineer. So they all still rely on a core aspect, which is, do you understand the technical concept? And if you do, then you can start making other decisions or other specialist decisions, choosing to specialize into other areas.
Yeah, it's really good advice. It's really good advice. And if you look at the industry as a wider piece, coming out of the E slightly, what do you think's coming up and coming in the industry? Anything that you feels impacting the sector?
So I think, although I've not been heavily involved in it, you can see that the L5 autonomy is more challenging than I think everyone wished or hoped it would be.
Definitely.
And that's still proving a real challenge to bring online. I think only this week we had the announcement for Ford bringing online their hands-free motorway driving, which is an interesting one when you look at it compared to where Tesla were a number of years ago in producing that. So the autonomy aspect is a big one. I'd love to be able to commute to work and actually work and sit in the car and not have to drive to work, because I'd spend more time being productive. But then I think the other things that we've recently experienced, I think all the OEMs have gone through this, and you can find this in publications, is the supply chain interruptions and shortages. So with those issues experienced in the silicon market, the impact it's had on a number of OEMs in a number of different ways. There was no plan, there was no expectation of shortages of silicon, and suddenly you're into massive design changes because of a pure issue outside your control, somewhere down a tier 1, 2, 3, level 4. Sometimes you just had no sight of this sub-supplier who suddenly can't produce you parts, or there are no parts, and you're having to make a massive change. So hopefully we're coming out the back of that now, and we'll see less of that, and the market's stabilizing again. And therefore you can expect to produce the product you started to design in a number of years in the future, rather than find out as you get to production that part's no longer available. And I think obviously the architecture changes are coming. The zone architectures or the centralized CPU, they are starting to get off the ground. I think everyone who, as the OEMs, as they've gone through the transition from the one function, one ECU design in the first instance, and that first leap they make outside of that, merging of domains, geographical domains, or a central CPU or an ADAS platform, when they've done that, they've all had a realization of how complex and how much more than just the product it is that you're changing. You have to change the way your teams work, the tools you use, the processes you use to produce something, how you develop the product, the time, the processes you use to use it. That they all change or influenced by what the product is changing electronically. And so they are coming, but they are, certainly in my experience, they're harder than everyone expects. And so once you've gone through that journey once or twice, you start to realize it's going to take a little bit more time than everyone expects, maybe. But they're coming. They just need a bit more time, and they are really, really big, complex ECU projects to take on.
Absolutely. Ultimately, there's a lot of talk, isn't there, that the DNA of a car, it's already happening as such, but the DNA of a car, especially in the next 5-10 years, will be primarily software. And it's, I think what we've seen, and it's very speculative at the moment, but what you're seeing in the market and what people can probably expect is the gateway into automotive competition. So we look at OEMs, we look at the usual suspects, the BMWs, we look at the Audis, the Jaguar Land Rovers, you then go in the motorsport world. Actually, the gateway into designing the car could be more software-based, and that's why you see companies, I don't even see the likes of Apple or Google, and that's where, so the automotive industry as a piece could ultimately widen as well.
Yeah, definitely. Yeah, you're going to get new players as well, as defined by us being a startup. The opportunity is there now for people to define their vehicle in more than just the existing standard way. So whether you look at Volta or people like Rivian or what Arrival are trying to do or anything like that, they are huge disruptors to the existing market, and they come at it with a very different solution. Sometimes the product itself, sometimes the way they do it, where their background comes from. If we talk like the Google and the Apple type concept of them moving potentially into the space, that there are very different ways of doing it, and it's good for the industry because it will generate change and it will improve things.
Which leads us nicely into the next question. So, based on all your experiences, why develop a career within the automotive space from your perspective, Grant?
So I think even if you don't end up moving into the automotive space, if you consider that electronic engineering, so software in hardware, if you consider that as a first step, I think you'll find if you look around you, nearly everything that works or functions in your house, in your car, where you work, there's a bit of software running on it somewhere. If you want the pure definition of a role that I don't think is going away in any time soon, even with all the current AI changes, I think the fundamentals of inventing solutions to problems in ECUs, whether it be embedded software or Windows-based systems, that they are the fundamentals of what is a good and stable career, I think, for engineers. And if you like the automotive, then great. It's somewhere in the middle of the balance between sort of your longer term projects like aerospace and marine, which in your 10 plus years, and you might find it hard to see the end product come to fruition because you've got to stay around for a long time. Consumer electronics runs really fast, puts to market things much quicker than you'd expect because the market's demanding it. People are willing to take more risks. You can't do that with a safety system in a vehicle. So vehicle and automotive electronics is sort of for me a good balance between the pace and the risk and the other methodologies like security and functional safety, which give you some stability, and you see the product, you get hands-on, you get a chance to be in the vehicle. These are really, for me, tangible benefits of working on a product. You work on an aerospace or marine project, you're probably never going to get in the plane or go in the boat. If you work on consumer electronics, you'll play with it, but it'll be in a really high pace and fast environment, which is slightly more risky. And generally, they put to market products which are still undergoing a development fundamentally. So yeah, I like the automotive balance, but I like the fact it's built off a core piece of skills and roles. I just don't see it going away. The core engineering concept of electronic engineering, I think, is here to stay for quite some time.
Thanks for coming out, sharing your career, sharing the trends, covered some really interesting points there, and appreciate it.
Thank you very much.
Thanks, Grant. Thanks very much.
Cheers. Thank you. Bye bye.